Welcome to this explainer. Today, we're going to dive right into the mathematical engine that really powers dynamic decision-making. We're talking about conditional probability. It's basically this incredible framework that allows us to update our odds in real time the exact second new information arrives. Let's get into it.
So have you ever actually wondered how probability changes when you already know that something has happened? We so often default to thinking of odds as these fixed, static things. Like a coin flip is always 50-50, right? But in reality, probabilities actually shift the moment you get to peek behind the curtain and gather a new clue. And that real-time adjustment is exactly what we're going to be breaking down today.
Okay, let's dive into this. Information changes everything. The card deck example. Imagine you've got a standard deck of playing cards. You draw one, but right before you flip it over, I give you a little clue. I tell you, hey, the card is red. Now what's the probability that it's a heart? Well, suddenly we have this clash between our old reality and our new reality. Because we know it's red, we're no longer considering the whole 52-card deck. Our entire universe of possibilities just shrink down to focus only on the red cards.
So, to formalize that intuition we just built, conditional probability is, quite simply, the probability of an event occurring given that another event has already occurred. You see, we aren't just calculating odds in a vacuum anymore. We're calculating them based on a newly met condition.
Now, what's really interesting here is how this new reality plays out visually. Our sample space is now just 26 red cards. The black cards? Totally gone. Entirely removed from the equation. And since exactly 13 of those red cards are hearts, our probability is simply 13 divided by 26. Just by knowing the card was red, we dynamically updated our math to a clean 50% chance. Pretty cool, right?
All right, let's move on to the mathematical formula, translating our intuition into actual math. Okay, so here is the formal equation. The probability of event A happening given event B equals the probability of A and B happening together divided by the probability of event B alone. That little intersection symbol in the middle, that simply represents the overlap where both conditions are true. So thinking back to our card example, B was the condition of the card being red, and A was the event of the card being a heart.
Let's actually run these mechanics through a quick, abstract calculation step by step. For step 1, let's assume event B has a 65% chance of happening. For step 2, the probability of both events overlapping, that intersection we just talked about, is 30%. Finally, in step 3, following our formula, we just divide that intersection, 0.30, by the condition, 0.65.
And this brilliantly illustrates how it all comes together, because running that math gives us roughly 0.46. So the probability of A happening, given that B is absolutely already a reality, lands right at 46%.
Now for the fun part, real-world applications, beyond the cards.
Because let's be honest, this goes way, way beyond textbook exercises. As humans, we are notoriously terrible at intuitively estimating probability. We tend to just go with our gut and completely ignore the actual math. But conditional probability is literally the exact logic keeping so many of our modern systems running smoothly. Weather prediction models use this to update forecasts dynamically based on shifting atmospheric pressure. In medicine, it's absolutely crucial. It's how we determine the actual likelihood of a disease given a positive test result, which actively protects us against false positives. Machine learning relies heavily on it for pattern recognition. And honestly, it's the exact logic your email spam filter uses every day to ask, okay, given this email says the word winner, what are the odds it's actually junk?
So, to wrap up, I really want to leave you with a simple but incredibly powerful question to carry into your own data analysis. Do I already know something that changes the outcome? The next time you're out there evaluating risk or trying to predict a trend, just remember, every single new piece of information literally shrinks the universe of possibilities. Thanks so much for joining me on this explainer, and I'll see you next time.